have a thermos bottle, you have a door flask. A lot of the things we use in science, we have at home to just give it a different name. Thermos bottle, door flask, the same thing. All of you have ovens in your house. In my lab, we call it an incubator. It's the same thing. They just charge you a lot more money for it. So, in here is liquid nitrogen. I also used to work at the Kennedy Space Shuttle where the space shuttle would take off. The external fuel tank for the space shuttle is nothing but a giant thermos bottle. It holds 555,000 gallons of rocket fuel. So I put this picture here so you can see people standing at the base of the space shuttle, get an idea of how tall it was. The rocket that's going off now, the Falcon Heavy, is only a little bit taller than the space shuttle. So you may look at that orange tank and think that's the biggest thermos bottle you've ever seen, but actually these are the biggest. This is a liquefied natural gas cargo ship. Each one of these round things is a thermos bottle. So I used to live in West Virginia where they do fracking. They take gas out of the ground, they make it so cold, they put it in a thermos bottle. As it goes across the ocean, a little bit of the liquid turns to a gas, comes down the pipes and runs the engines. These ships need no external fuel at all to operate. All right, so we want to get an idea of how cold this stuff is. Raise your hand if you've ever had water in your hand. Raise your hand if you've ever had ice in your hand. How about this? Who can tell me what temperature water turns to ice?
32.
0 degrees Celsius? What's the Fahrenheit temperature water turns to ice? 32. Who can tell me what's the third temperature scale?
Kelvin.
Kelvin. All right. So here we go. 100 degrees Celsius, temperature water boils. 0 degrees Celsius, temperature water freezes. Dry ice is a -78. Liquid nitrogen, -196. So this liquid is 196 degrees colder than ice in your refrigerator. So I'm going to pour some out. This is also a thermos bottle, through a flask. See, I keep my juice in there. Okay. Oh, wait a minute. It's had a little bit of dirt in it.
Hold on now.
I'm sorry. So I just threw our liquid nitrogen out. Is our floor wet or dry? Dry. It's dry. So it's draining outside in the ground, and it stops raining. What happens to the water on the ground? It evaporates away. So let me ask you this. Is evaporation a physical change or a chemical change? Raise your hand if you think it's a physical change. Come on, don't be scared. Put your hand up if that's what you think. Raise your hand if you think it's a chemical change. Evaporation is a physical change. You can tell something's a physical change because it's reversible. So when I throw my liquid nitrogen out, it turns into a gas. If I collected the gas and made it cold, it'll turn right back into a liquid again. You light a match, chemical change, can't go backwards. That's how you can tell. All right. Aromatherapy, y'all. Okay. We're going to do a little experiment. My man, let's go. Yep. Blow that balloon up for me. So, while this young man's blowing this balloon up, I want you to notice I'm using a clear balloon so you can see through it. His air does not have a color. The air in this room is the gas. Can you see the air in this room? No. No, you cannot see a gas. When we breathe, what gas do we exhale? Keep going, boy. When we breathe, what gas do we exhale?
Carbon dioxide.
Carbon dioxide. Frozen carbon dioxide is a white solid called dry ice. If we exhale carbon dioxide and we freeze it, what should we see on the inside of this balloon? Dry ice. Okay. Ew. You just nasty. All right. So if we exhale carbon dioxide and we freeze it, we should see dry ice on the inside of this balloon. Okay? We're going to put this balloon in liquid nitrogen. So first of all, how many people saw the movie Terminator 2? This is my favorite scene in the movie. If it'll run.
That's a good movie.
The robot, the T-1000, crashed in a tanker truck of liquid nitrogen.
Right.
While he's walking through the liquid nitrogen, he's gonna start to freeze. Safety glass.
Oh.
Now remember, this is a robot, not a person. So we understand. So once he's frozen, the hero of the movie, the other Terminator, Arnold Schwarzenegger, is going to shoot him with a gun. He's going to shatter into little pieces. We're going to put this balloon in liquid nitrogen. The balloon can freeze solid like the Terminator. The balloon could get bigger, the balloon could get smaller, or it could pop. Raise your hand if you think it'll freeze solid. Get bigger. Get smaller. Pop right away. What do you think? Pop. Pop. Okay. What I want you to do is hold the balloon with 2 hands. I'm gonna pour liquid nitrogen into the bowl. You're gonna put the balloon down into the bowl. Now don't let go, don't be scared. All right. All right? Okay, nice and easy.
What's it doing?
What's happening to the balloon? It's getting smaller. So think about this. In this balloon is his air. As he pushes the balloon down into the liquid nitrogen, a little piece of air getting cold, so they're getting closer together. Suppose you're laying at home in bed and you're cold. You don't lay like this. You curl up like that. His air is curling up, trying to keep his heat, so the whole balloon is getting smaller. This gives us an idea that as things get cold, they contract. Push. Hands on top. Okay, where your hands? Notice it looks like a Hershey's Kiss? I'm gonna push down the rest of the way with my spoon so we don't get our hands in it. Okay. He's gonna grab the balloon by the edge and lift it up. When he does, you'll see a white liquid in the bottom of the balloon. You will not see just dry ice on the bottom of this balloon. It is incorrect to tell students we exhale CO2. That's wrong. The air we breathe in is 78% nitrogen, 21% oxygen. The air we breathe out, 78% nitrogen, 16% oxygen, 5% carbon dioxide. Most of what you exhale is nitrogen and oxygen. They don't do anything, so they don't tell you about it. We do exhale a little bit of carbon dioxide, which is part of the carbon cycle, but only a little. So he's going to grab the balloon by the edge and lift it up. Then the two of us, we're going to blow this balloon back up from the outside. So this is his air right here. Now watch what happens. Let go. Blow. Keep blowing. You see a little bit of white stuff? That's the little bit of CO2 that we exhale. It is a solid that turns into a gas. That process is called sublimation. It is also a physical change. The balloon is still tied off. None of the air came out. It's the same air that was in there before. All right, good job.